Hey everyone, in this video, actually within the next couple videos, we're going to be looking at investing money. And this is always an interesting concept because it's talking about money and has some very good applications. Now, we're going to start with looking at investing money with compounded interest. So here, for the first part of this next section, we're looking at having a single lump sum. Meaning we're having a single lump deposit, I should say, not really sum, but more of deposit. So I have a certain amount of money, I deposit it into an account, and I just leave it alone. And from interest, I gain money to it. So here we have this lovely formula. You can see it above as well. Okay, and looking at this, I want to say that this R divided by K, this value, when you actually divide the two, we actually see that this is the interest rate per compounding period. And I feel like I should talk about what it means to have a compounded interest. So typically, when you invest money, there's a certain interest rate, and that interest rate adds on to your current amount. And sometimes, most of the time, we've been looking at just once a year. So at the very end of the year, it looks at what you have, and it takes a certain percentage and adds that percentage back on to what you have. Compounded is every so often. It could be every month, it could be every week, every day. It could be 4 times a year. You are doing that. You're taking what you currently have and adding it back on to your current amount. So that's what it means when it says compound, is that you're adding interest more frequently, or at different rates, I should say. So there are different possibilities of how we can compound the interest. I said most of them already. So our compound is, this would be our K value. We have annually, so that's once a year. There our K would equal 1. We have quarterly. So thinking of quarter, that's 4. We have monthly, 12. We have daily, 365, and getting more and more, our period becoming more and more frequent. This is going to be eventually continuous. This is not even, this is like more than every second. This is constantly, we're gaining interest on our current amount. This gains a whole new formula. So when we're compounding continuously, it has a whole new formula compared to a more defined compounding period. Okay, so these problems are truly just plugging numbers in. So let's look at an example. So I made this example more for my curiosity. I was curious as to see what would happen. So let's say I open a savings account. For my kids. This is basically to help them with their college tuition. Okay. So I wish to have $60,000 by the time they graduate. Okay, we're going to assume 17 years for this. So that's going to be important here in a little bit. If the savings account that I'm looking at earns 9% interest, compounded monthly, how much should I deposit initially? Okay, so I'm looking at all of this and pulling out the key items. We see our amount that we desire, so this would be our A. We see the rate, 9%, so 0.09. We know our compounding period, which is K. This would be monthly, so that's 12. And we also see that the time that we're looking at investing in is 17 years. Okay, so with all of this, again, writing our formula down. And plugging values in. Okay, so in doing so, I'm going to simplify this right side. Let's do this. Okay, so 1 plus okay. Doing so, I get roughly 4.5919. Okay, so I just want P, so I divide by this value. And we find that we get $13,066.52. All right, and that's it. So believe it or not, if I desire to save up to $60,000, having the savings account with an interest rate of 9%, I need to deposit $13,000 into the savings account initially, and just let it be for 17 years, and after 17 years it builds up to $60,000. Okay, so let's try another. Last one, believe it or not. So Edwin has $500, and he wants to invest it in this account he's using. He's investing at 6% annual compounded interest. So it sounds a little awkward there. How long will it take for his investment to grow to 2,500? All right, so we're using this same formula. Okay, so we know what our initial is. we're initially putting in $500. We know what our rate is, 0.06. The compounding period says annual compounded interest. We're compounding annually here, so our K would be 1. And then our amount that we desire is 2,500, and we do not know the value of T. That's what we're looking for. So placing everything in, and we find, let's see, what's 1 times T? I think I could just write T here instead of 1T. Okay, so you're writing this. I believe this is just going to be 0.06, so 1 plus that. Okay, and I'm seeing an exponential function or equation. How I know that? Well, the variable is in the exponent, so exponential function. So I have to isolate this term. Let's divide by 500. We divide by 500. This is going to be 500. 1.06t raised to the power of t. Okay, so to unlock this, let's take the natural log of both sides. I could do log base of this, but that's not good. So natural log of both sides, and really using the natural log is okay. And you'll see why, if you don't already know why. Well, the reason's right here. In doing so, our property allows us to pull the exponent down, so the t comes out front. Which just makes this a division step. So, and just like that, we were going to have our answer. Natural log of 500 divided by the natural log of 1.06 gives us 100. Did I do something right? Something's not right here. Oh my goodness. You're probably screaming at me, Mr. Beal, what did you do wrong, or why didn't you do this? 2,500 divided by 500 is not that. I would believe that that's just, 5. Okay. So again, I got the reason why I knew something was wrong, if you were not really following the little steps with me, I got 106. So we're saying here it's going to take Edwin 106 years to go from 500 to 2,500, and that just wasn't right to me. So let's try this again. Natural log of 5 okay, and that gives us much better, 27.6. Okay, or we could say 28 years. So I made a quick assumption. I have my notes right beside me, but going back and fixing this, it made our answer much more realistic. So we have 28. After 28 years, Edwin has his desired amount. Okay. So to close this video, this short lesson, I would like for you to do this one last problem. I would like for you to examine this problem. Eugene, he wants to invest $1,000. Which is better for him? Which one's more attractive to him? Depositing the money into an account with 6.5 annual interest compounded continuously, so we have to use that unique formula, or if he has an account that has 8% interest compounded daily. So which of these accounts is going to be better for him? And I think we can understand that the one that earns him the most money is obviously going to be more attractive. So go ahead and do this, and we're going to come in, practice this more, look at more scenarios with this, and discuss more about money and investing.